Good morning, everyone. Today we are doing a post-order tree traversal question that was on a real data structures exam, my data structures final, and we're going to apply what we learned in my last video about tree traversals for this question. So, let's get started. Okay, here's the question. Given the BST with a post-order traversal of 3, 2, 5, 4, 7, 8, 9, 6, what's the third value of the pre-order traversal of the same tree, index 2 in array? Okay, so this question is asking us to understand BST and post-order traversal and also pre-order traversal. That's a lot for this one question. So what does this mean? What do we have to do? What is this question asking us? So first, it's saying to construct the tree from this post-order traversal. Construct the BST from this post-order traversal. And then you want to give the pre-order traversal of it the third value of that pre-order traversal. Okay. So how do we do that? Let's see what they tell us. So maybe we're familiar with being given a BST and then performing the post-order traversal on that. But here, it's backwards. They gave us this array, which represents a BST. And what do we know from this array? Because this is a representation of the array, of the tree. So it's a post-order traversal. So what I drew over here is just an image, just like a little picture diagram. Oh, I guess like a little diagram that helps me remember the order in which we visit the nodes in each of the tree traversals. In the left column represents the left node, the right column represents the right node, and the middle column represents the current node, or root node. And so for post-order traversal, it says we visit the node on the left first, then we visit the node on the right second, and then we visit current node last. And as we saw in my last video, that would mean because the root node is visited last as a result of the recursive calls getting called down, down, we don't actually see root node until the very end. And so that means 6 is the root node of this tree. Just as a fact of post-order traversal being that root node is going to be the last node we see in this post-order traversal. Okay, what else can we gather? Well, because this is a BST, that means everything to the left of this root 6 will be less than 6, and everything to the right of 6 will be greater than 6, the right subtree, right? Okay. That means all of these values, because their value is less than 6, will be on the left, and all of these values will be on the right because they're greater than 6. Now we just need to figure out how to jigsaw them into their subtree. We're still in part 1, by the way, constructing the tree. That's not clear. Okay. So we know this is going to be on the left, and this is going to be on the right. And now let's put on our sort of post-order deduction caps, and let's see. So we would look at root, and we'd want to look left, do the recursive algorithm again, look left, or right, whatever we do until we get to a leaf, and then we can recurse our way back up the tree. So that would mean that 3 is a leaf. So we'll just put 3. It's over here, it's on the left. And now we have to ask ourselves, where would 2 go? Could 2... So since 2 is seen after 3, remember post-order, that would mean maybe 3 is a left child, and then 2 is a right child. But that doesn't make any sense, because if it were, that would mean 2 is greater than 3, because it's a BST, but 2 is not greater than 3, so 2 cannot be the right sibling of 3. That would have to mean that 3 could be a right child and 2 is a parent. So let's draw 2 as a parent. And we gather this because 2 must be evaluated after 3, and 3 must be a child. In another case, maybe a sibling, but here it is a child. Okay, nice. Now we have to figure out where 4 and 5 go. Well, first, let's verify that this is correct. So if we start, let's pretend this is our entire tree, right? We start at 6, and we want to look left, step 1 of Postorder. So we look at 2, but we don't visit 2, we want to look left, nothing here, then we want to look right. Okay, now we can mark 3 as visited. Then we go back up the tree to 2. 2 is right there, we just checked both left and right subtrees, so then we can visit 2. Then we go back up, and 6. That matches. That would confirm what we'd have so far. So we've seen these two. Okay, and now let's figure out where 4 and 5 go. So it's a similar case where 5 is a greater value than 4, and 5 is evaluated before 4, and we know because our tree is a binary search tree that 4 and 5 have to fit somewhere in here, somewhere in between the 3 and the 6. So since 5 is evaluated before 4, it could be a left child or a left sibling, or a right child to a middle parent, but 5, remember, just like in the case of 3, I should draw the circles, because these are nodes. In the case of 3 being greater than 2, we can say that 5, is the right child of 4. Oh, jeez, this tree is looking horrendous. Is there a way for me to move? How do I grab? You know what? It's fine. So 4 is the left child of 6, and I will just redraw these for my own sanity. 2 is also a child of 4. 3, sure that'll do. 3 is the right child of 2, and 5 is the right child of 4. So we can do the same verification of doing a Postorder on just this. We'd start at 6, look left, look left, look left, nothing here. Then we can look at right, then visit the root, go back up. We don't want to visit the root yet, we want to check right, okay, then 4, then 6. So this all matches. And now we can look at the right subtree, 7, 8, 9. Haha, okay. Same idea, 7 we know must be a leaf. The same idea as 3, in that on the right subtree we would recurse all through the tree. Like say there's a node here. We want to recurse all the way down until we got to a leaf, and then we can begin recursing back up and looking at the other nodes. So let's say that 3 is a leaf somewhere. Now, how does 8 fit in? So 8 could be a right sibling or a parent, and in the case that, I think we can actually knock out both 8 and 9 in this one step, because 7 must be evaluated before 8, so that must mean 7 could be a left child and 8 a root or a right child. But if we said that 8 were a right child, which means 9 was a parent, 7 would be evaluated, and then 8, and then 9 via post-order traversal. However, this violates BST ordering because 8 is not greater than 9. And so that means our only way could be 8 must be a parent to 7, and then 9 must be a parent to 8, because this satisfies BST ordering and post-order traversal in that you'd visit 9, you'd look to the right of 8, nothing, then you'd visit 8, then you'd go back to 9, you'd look to the right of 9, see nothing there, then you could visit 9, and that satisfies post-order traversal. So we just constructed the tree. It took a while, but that was the hardest part. And now you have to pre-order traverse the tree. Oopsie. Pre-order traverse the tree. Okay, so let's see what I have written here for pre-order traversal. Highly recommend giving my traversal tree video for more in-depth explanation of how this works. This right here might just look like abstract numbers, but we actually go through some examples in my other video. Okay, so it says, first we visit current, then we look left, and then we look right. And this is a recursive algorithm that we repeat on every single node. Okay, so let's stick with highlighter. I have highlighter everywhere. My history teacher in high school would be so mad. Well, let's get rid of some of these highlights. Juvenile. Okay. So we start at 6. We can mark 6 as visited. Let's call this our pre-order traversal array. Now, next step is look left. In column 2 is the left nodes. Now we'll look left. Okay, now this is our new current. This is the new current. Our algorithm says mark 4 is visited. Okay, 4. Then it says look left again. 2. 2 becomes our new current. Then we can mark 2 as visited. What is the third value of the pre-order traversal? We can stop because we just found our third value of our pre-order traversal. This was 1, 2, 3. And in our array, this would be index 1, index 0, index 1, and index 2. Index 2. And so 2 is our final answer. There you have it. That is the pre-order traversal, or the third value of the pre-order traversal of a BST that we had to construct just from a post-order traversal array. Okay, I hope that helped, being able to see my thought process on a real exam question. And good luck with your studies, everyone. Stay safe. Have a good day.